So I did grade it. I suppose we'll go over the test. Take a picture of it, pass that. Everybody can make sure I graded correctly. Anything in particular y'all want me to go over? Like any of them you have wrong that you want to go over? No, really? I had planned to go over it. I forgot it was a Friday. So,
could you go over 24 and 25? And if it's not understanding it,
okay. So the arrow represents the process that's occurring. And the process that needs to occur is for this to be an acid, for it to be BO acid, this process needs to show this giving up an H+. So that's that should be 2. Does that make sense?
yeah.
And then the base is the opposite. Base shows it accepting an H+. This is already negative, so it should be H2. Makes sense now? And 25 is just the same. You see the H2PO4 giving up one of its outright. It's negative, right? You could look at it like this. No, that doesn't work for this problem. And then the base would be accepting H+. Makes sense. Any other questions? Does that get around everybody? Do look and see that I graded it. You make mistakes. You think they can read that? There, for our viewers at home. Nothing else you want to do on here? You sure? I am just going to go over, let me show you on D2L here. I said D2L. I've added this Word docs for practice for test 3. find something good because I didn't do a very good job explaining things today. So I'm kind of just going to go back over those things. So today I go back over balancing. But if you go up to content and then you go to Word docs or practice for test 3, and look at one balancing redox reactions website. Look at that. What I've got in there is just a little bit of description and a link. It's a good link for a bunch of practice problems on finding oxidation numbers. And then down here, I've got 2 more links. One link to balance reactions in basic solution and one in acidic solution. And that's what I'll go over today. But my description there says to look at the Word doc. You can look at the website. They just go over some slightly more complex ones that I won't do. Let me fix those. That took us to base. The Word docs that's referring to are these 2 Word docs under Word docs for practice for test 3. I'll go quick. Can't find it yet. Anyway, so these documents, they just look like this. And it's just a bunch of these balancing problems. That's what we have to print out in here. So I'll go through a bunch of these. I'm going to put these on D2L as well. But if you want something to look at for now. So just to point out, under Word docs for practice for test 3, I've got some balancing stuff on there that you can practice. And I'll go back over it. I know I didn't explain it well last time. So, can you not find your test?
No, I don't think I have that.
Okay, so balancing. So here's an example. You're given ClO3 negative, so 2 uncharged. Start with that. The next thing you want to break it down into is the oxidation half reaction and the reduction half reaction. It doesn't matter which one you do first. I'm going to go ClO negative. Cl is really oxygens and hydrogens that you might bring down from up here. You're going to balance them with using water and H+. So as long as you have the other atom here, that's what you're doing. So you've got that, and now I'm going to do SO2. You start by writing the half reactions, and then the first thing to do is to make sure everything except hydrogens and oxygens are balanced. As long as you follow these rules, you won't get hung up anywhere. The chlorine is already balanced. The sulfur is already balanced. So now I'm going to look at oxygen first and go, okay, oxygen, I need to balance that by adding H2O. I've got 3 oxygens over here and none over here. So I'm going to go plus 3 H2O, and that gives me 3 oxygens. So now the oxygens are balanced. Down here, I've got 2 here and 4 oxygens here. I need to go 2 H2O. So now the oxygens are balanced, top and bottom. Now I've got to balance the H+, or the hydrogens. I've got 6 hydrogens here, so I've got to put 6 there. This one, I've got 4 hydrogens here, so I've got to put 4 over here. Okay, are you with me so far? Everybody good on that? All right. The next thing to do is to figure out how many, you've got to put some number of electrons in here. This I know I didn't explain well last time, so let me put it like this. You can only put in negative charges, and when I say balance, I say there's this side and there's a total amount of charge on this side, and on this side there's a total amount of charge on this side. All right, first, I have 4 positive charges from here. So I'm going to say plus 4 from there. And here, there's no coefficient here, but I've got a -2 charge. So I've got -2. And what I would tell you to do is, what does that mean? Plus 2. And over here, I've got no charges, so I'm just going to say my overall charge is 0. So if my overall charge over here is plus 2, and my charge over here is 0, and I can only add negatives, which side am I going to put my negatives on? That's plus 2. If I put some negative charge over here, that can only bring us down below 0. That's not going to help at all. What we want to do is add some negative charges over here to make it match this side. So how many negative charges do I add over here? 2. If I do plus 2e, that makes this side 0, and now both sides are charge balanced. You follow that? Okay, I'll do more of these examples, but I think that's what I skipped over too quick last time. Now let's do it up top. What's our total charge up here? We've got -1. And over here, what's our total charge?
Plus 5.
It is, it's plus 5. You've got 6 plus here, I'll say plus 6, because there's a 6. And you've only got 1 negative. So these two, add those two together, that means over here we're at plus 5. So where are we going to add the electrons? If we add electrons on the negative side, we're just going to go down. We've got to get to +5 if we're going to add over there. So we don't add over there. Another clue is you're necessarily going to add to the opposite side that you added for this one. So yeah, we're going to add to this side. We're at +5. We need to get to what? We need to make this side a total of -1. So how many electrons are we adding? 5. Yeah, 6. So 6. Yeah. Quick double check. 6 pluses, or 6 negatives and 6 pluses, those cancel. And you got a total of just this one negative, but that's what we were after. So that's how you get your electrons. The next step is to make the electrons balance by multiplying through. I've got 6 electrons here and only 2 on the bottom. So I need to multiply through here by 3. So 2 times 3 is 6. 1 times 3, 1 times 3. 3 times 4 is 12. And 2 times 3 is 6. There, now the electrons balance. Okay, the next thing to do is just to bring everything down. Bring everything down. You can, now that you balance the electrons, we can go ahead and chop those out. I'm not going to bring those down. So get rid of that. I have 6 H2O over here and 3 H2O over there. You could deal with that with this step before you write everything down, but let me go ahead and bring everything down. I think it works better, at least to my brain. I don't get lost. I've got 6 H2O. I've got 6H plus. And then these ClO3. 3SO2, those over here. Let's put the H2O first. And 12 H pluses, I'll put that next. And what I put here, the Cl, so I'll put plus Cl negative. 3SO4. 2 minus. Everything is balanced, but we can cancel some more stuff. So what we're going to do is, we've got 3 H2O over there and 6 here. So I'm going to subtract. So now I've got no H2O here. And is that 3? So that leaves me 3 H2O left over. All right, I also have H plus on both sides. I'm going to subtract 6 H pluses to get rid of them on one side. Excuse me, 6 H plus left. And I think that does it. So it's 3 H2O plus Cl 3 minus plus 3SO2. And over here we have 6H plus and then plus Cl minus and plus 3S. And that's it. ClO, 3H2O, 3SO2, 6 H's, Cl, 3SO2. Did it right. You follow that? It's a lot of steps, but if you practice a few of these, I think you get it. Another example. let's start with H2S. Which one of those am I writing down here? That's 8. Okay, what do we do first?
Add H2Os.
Not quite. There's one step in between. You balance everything that's not. If you follow these rules, you won't go wrong. So don't forget this one. Balance everything that's not H and O first. The non-H. I mean, look, you got S here and S8 here. You're going to want to deal with that first. So I'll put an 8 here. I have introduced some H's, but let's deal with, let's keep going in order here. I've got one N and one N, so we're good there. The next thing is the oxygens. I've got no oxygens to deal with up here. Down here, I've got 3 here and 1 there. So I'm going to put 2, these 2 O's here. So now I've dealt with all the oxygens. What's next? Hydrogen. I've got 2 times 8, 16 hydrogens here, and none over here, so I have to put just the one that gets to huge numbers. End up with a 48 somewhere eventually. Or was I? Okay, 4 hydrogens over here, none over here, so I've got to go. Now we charge balance. 4 there and a 16 there. According to this, I've done something wrong already. 4H plus. Oh, no, that's fine. That's fine. Okay. Next is the electrons. All right. What's the total charge on this side? Plus 16. There's no charges here, but there's 16 H pluses, and the charge over here is 0. So where do we put the electrons? We're 0 here, and we're positive here, and we have to add negative charges. We're stuck balancing by adding negative charges some. So all we can do is add 16 negative charges over here. You see what I'm saying? You guys see that? The only way to make these balance so that makes that 0 and this side is 0. All right, down here, what's the charge on this side? Got a -1 there, and you've got +4 here. So we're at +30. And we're at 0 over there, so of course we have to add the electrons on this side. So we need -3. So we should be charge balanced now. And it's not always true that you're trying to get to 0, because this side was 0, this side was 0. But we do have them charge balanced. Okay, it's the 3 and the 16. And so far I'm doing this right. So what you need to do is multiply through in some way to get the electrons to balance. You can multiply both of them in some way, and that's what we have to do here. Least common multiple, I think, is ultimately what we're trying to do. So if we multiply this by 2, we get 32, but we still can't get there with a 3. If we multiply this by 3, what's 16 times 3? 30, 18, 48. Is 3 divisible by 48? I don't even know right off the top of my head. 16? Oh, you multiply 3 times, yeah, okay. Okay, so yeah, we end up having to go this times 3, and this times 16. Right? So we'll get 48 there, we'll get 48 here. All right. Multiplying by 3. 3 times 8 is 24. 3 times 1 is 3. 3 times 16 is 48. 3 times 16 is 48. And then times 16. 3 times 16 is 48. What's 4 times 16? 32, 64. Is that right? Two times 16 is 32. 2 times 32 is 64. And multiplying by 16. 16 there. Multiplying by 16. 2 times 16 is 32. And now we can chop out our electrons. Bring everything down. There's no water over here, so we're going to end up keeping all that water. We got H plus there and H plus there. Like I said, you can deal with those two things before you bring it all down, but I get lost in things too easily, so let's go with 64H plus 24H2S plus 16NO3. And I'm going to put the H pluses first. Just to be consistent. 8. That's everything brought down, and then we're going to deal with the extra H plus. So we will subtract 64. We end up with 0 H plus. No. Backwards. Minus 48. H plus, so we get 0 there. Minus 48. Somebody do that in their head real quick. 64 minus 48. What is it? 16. That. 0 H plus over here. So, 24, 16, 16, 3, 16. Yeah, that's the answer to this one. In acidic conditions, basic conditions, there's one more step. Let's do another one of these though. You guys want to try one? That's 8 again. You guys want to try one? It's good practice. I'll start you off. Write that down on a piece of paper. And I would just grab this one first and make the half reaction. Here, I'll get you started. If you get stuck, just say so, and I'll add another step. Just trying to eat on your Friday. We'll get some more. Anybody stuck? Anybody stuck? Should I keep going? Are y'all ahead of me? No? You got this far, right? This far.
Oh, yeah.
Okay, want to balance this. And this, this is an 8. We get to huge numbers again. Yeah, still get the big numbers. Alright. S is balanced. And N is balanced. I want to do oxygen next. Four oxygens. Now, no oxygens down here. So hydrogens, I have 8 hydrogens. Down here, I have 16 hydrogens. And now we charge balance by adding electrons. How many electrons did y'all? What'd you do with electrons up here? Decide how many? Total charge over here is +2. Total charge over here is +8 and -1, +7. So we've got to get these to match. If we start putting negatives here, we get further away from +7. So we're going to add to this +7 to get it down to 2, and that was, how many did you say? 5?
I
Is-
forgot there was a negative.
Okay, but it's 5, right? Is it 5?
Yes.
Yeah.
5, 6, 7. Okay, so we need. And now both sides should be +2. Down here, where you put the electron, well, you're definitely putting them to the right side. So with these to the left. But this is 0, and this is 16 plus. The only way to make a match is to bring these down by 16. Yeah, I guess we end up multiplying this by 16 and this by 5. 32, 48. 60. 60, right? 42, it's 2. 48, 60. We multiply this by 4, we get 60. And I know we can do that and get to 60. We've got 40. That's right there, isn't it? Right? 5 times this is, whatever. 5, let me ask you this, is 5 times 16 60?
It's 80, I think I just funded.
5 times 16 is 80. Can't do math in my head anymore. So what do we multiply this by?
60.
So we have to just do that again, right? This times 16 and this times 5. What's 16 times 5?
80.
5 times 8 is 40. No, 16 times 8?
128.
16 times that. 16 times this. What's 4 times 16?
64.
These I can do. 5 times 8, 40. 5 times this. What's 5 times 16?
80.
Okay. That out. That out. All right. I'm not dealing with those. There's no water on those. So if we bring just those down, we're going to go minus 80, minus 80. 128 minus 80.
48.
48. Here we will have, and then I'll just bring those down. 48H plus 60. 40. These went to 0. You know, that's 8. So 64 is 2. Yep, that's what they had for the answer. I would probably stick to ones of these that have smaller numbers. I'm just testing your ability to go through this, not your ability to multiply numbers together. All right, one more reasonably low numbers. Balance everything that's not oxygen or hydrogen, but they're balanced. One's U, one's U, one S, one S. balance oxygens with water. There's no oxygens down here, so I don't need to do anything here. Two of those, right? All right, now I've got 4H plus to put here. H is balanced, oxygen's balanced. Okay, I guess we're good, right? Do electrons now? We're at +2 over here, we're at 0 here. So where am I putting the electrons? Two negative charges, so now this side is 0 and this side is 0. How about up top? This is 0, and over here we're net positive, so we're definitely adding over here. How many do I need to add? 4 plus, and then 2 negative, so we're at 2 plus over here. And there's no multiplying. Our electrons match. 2 electrons over here, 2 over there, so we don't have to multiply through by anything. Chop these out. Bring everything down. There's only water on that side and no H plus. There's no water over here and only H plus, so I think we're done once we bring it all down. There's a few more examples in this word. These I want to put on D2L though, but I guess it doesn't matter whether you do it on D2L or you do it on your own. I have my spreadsheet already made. Doing these on D2L.
Are you going to put all of the problems from the workout on D2L?
Yeah. You want more for practice though? It's just so it's there for practice. I'm going to put these in there so I have them next time I teach 12-12, so I already have it done. But you could use this or D2L to practice. Of course, D2L is going to show you exactly how I'm going to have it on the test. And I'll do it multiple choice. You're just going to have to pick out one of these among a bunch of trick ones. And I think the only way to do it is to go through the whole process. So doing it multiple choice doesn't really save you a long process. Just makes it easier for me to grade. I tried to think of a trick way. It seems like I remember trying to do that years ago. It doesn't go through all these steps, some more direct way, and I never came up with it. But I suspect there's some kind of algebra formula you could use. Okay, now we're doing under basic conditions. And it's truthfully, it's exactly the same except for one more step at the end. So we have okay, we'll start with nitrogen compound. Chlorine compound. Okay, what do we do first? Balance the what? Yes, we balance the equation. So we want to balance the nitrogens. So everything that's not oxygen or hydrogen, we want to balance first. Chlorines are balanced. Now the nitrogens are balanced. Now we're going to oxygens. No oxygens up here. We got this one down here. Now oxygens are balanced. Now we need to balance the H. 4 hydrogens here. We've got 6 over here. got 6 over there and 6 over there. And now we need 2 over here. All right. Neutral over here, charge 0. We're definitely positive over there, so we're definitely going to put the electron over there. We put electrons here, we start getting negative, and we know we're positive over here. How many electrons do I want?
2.
We got 2 positives, now we got 2 negatives. Now both sides are 0. This side is negative. What's the charge on this side?
+1.
It's +1. We got 2 positive charges and 1 negative charges, so we're left with 1 positive here. We can make it negative by adding how many electrons?
2.
2 electrons. Everybody follow that? Why that one was 2. All right, and no grand multiplying here, so chop out the 2 electrons, they already match. All right, 2 each plus 2 each 3 plus 0 over negative. Now we'll put H plus first. And we'll do the water. Into H4 plus L minus plus H2. All right. Now it's balanced for acid conditions. To make it base conditions, I guess if I wrote it in a rule, I would say neutralize NaH plus UC also adding saying this website does it slightly different than the book explains. So I'm explaining it the way the book explains it. Because you can do it all here. All right. So I've got 2H plus here and 2H plus here. So if I just add 2 OHs to both sides, what I'm saying is so we're going to be creating some H2O by doing this. 2H pluses, and now I'm going to add 2 OH. That's going to give me 2 H2Os here. The same thing's going to happen here. Add 2 OHs. Gives you 2 H2Os. And now if I bring everything down, I'm almost done. It's just that I've got H2O here. So I'll end up with 3 H2Os. In this case, since these 2 match, I could just subtract 2 H2Os right now. Let me do it like this. Two H2O. I think in process for some of these other ones I do, I'll probably combine the H2Os and have 3 H2O and then do subtraction. But since these already match, I'm just going to subtract 2 H2O from both sides. So that eliminates this. And that eliminates that. So subtract 2 H2O from both sides. And we're just left with this to this side. This, this side. here's what we did. That's what we did to balance these. We added that 2 and we added that H to it. I think this website mentions, hey, sometimes you can do this, but I've tried to figure out what's the conditions when it makes it that easy, and I think you have to go through all these steps to make it work. If you think you figure out a trick, then you have a trick. But it's funny that we go through all that just to find out there's a 2 there and there's an H2O there. Some of these, there's OH left over, there's water, more water left over, so I don't know how you make it more simple. I might be able to explain that one if we talk about electrodes again, in the context of the electrodes, but I'm going to skip that one for now. So we start with this. Manganese. All right. The manganese balances, the bromine balances. So oxygen, 3 oxygens there, so I need 4 there and 2 there, so I need 2 more over here. Now I have 6 hydrogens. Add over here. And I have 4 hydrogens here. Okay. I think this website is just always putting the oxidized thing first, because that's why we keep adding the electron over there first every time. Because I just bring this one down. So, what's the total charge over here? What's the total charge over here? Plus 6 minus 1 is plus 5. So we want to get to -1, so how many electrons do we have? So that'll take us from plus 5 down to -1. Electrons over here. That side's neutral. And we're at plus 3, right? You've got plus 4 plus -1. So currently, we're at plus 3. We need to bring it down to 0, because that side's 0. So how many negatives? 3 negatives. Now both sides are 0. 3 and 6 electrons, so we'll multiply through here by 3. 3 times 3 is 9. 3 times 4 is 12. 3 times 1 is 3. 3 times 1 is 3. 3 times 2 is 6. Yep, 6 is. 6 is okay. Oh no. What did I just do? How many electrons do we have? 3? I need to multiply by 2. And what was this? 4. 1. 1. This was 2. Okay. 2, that's 6. Y'all weren't gonna stop me. I'm so busy. 2, 2 times 2 is 4.
Why don't you add the OH before you do the charging?
That is another way to do this.
Because wouldn't it be 6 OH plus 3 HCl plus CR yields BR 3?
There is another way to do this that they mention on here, but I stick to one method because it always works. If you want to break it up some other way, you can read that website. It tells you when you need to do
If
that.
you were going to add the same number of OH to both sides as the same number of hydrogens, would you put 6 OHs on both sides?
Yeah, no, you would put 8 on both sides because you need to completely get rid of all the hydrogen. You need to completely get rid of all the H+.
I was talking about 3H2O plus Br yields Br 3 plus 6H.
3.
Because you have 6 hydrogens there and then 6 hydrogens on the other side. Would you do 6 OHs on each side if you add the OHs to both
I'm going to
sides?
get confused. Hold on. Let's go back to that step. Me confused? All right. Here we balance. Stop me when you're saying, bringing up what you're saying. Magnesium's balanced, bromine's balanced. So now we go to oxygens. I've got 3 oxygens over here, so I need there. 4 oxygens here, 2 oxygens here. I don't think I understood your comment. Okay, you good so far?
Like, for the first half reaction, the Br minus yields Br03 minus, right? And then to neutralize the hydrogens, you have to add the OHs, because the OHs are going to change the charge of the equation because it's -1. So if you have 6 OHs, and that's like -6 charge, you would have to add on to each side, which would change how many electrons you could have.
When we say charge balance, we're just making sure this charge balance side matches with the charge on this side. How many electrons you add is based on that.
Is based on like the charge, but if OH is a -1 charge and with 6 of them, then you have -6 because you have to deal the coefficient in front, right?
Well, just as an aside, if you had 6 OH negative, yeah, that's 6 negative charges. I'm not sure I understand what you're asking.
I'm just confused, like why don't you just add the OH like when you start? Because that just makes the electrons.
We need, okay, the next step is doing the hydrogens. Let me put those in. 6 hydrogens here. And 4 here. And you're saying, why don't you just go ahead and add your OHs and take care of that?
Yeah, like why don't you just do it all in one step instead of
Um,
taking them back?
This is the step where we add the electrons, and we need to get those first before we start tinkering with anything else. And then the next step, yeah, you could do the OHs next. But you're saying you would include the OHs somehow when you think about the electrons?
Mm-hmm. Like you can just do it all in like one thing.
Well, now that we know how many H's we have, all right, let me see. Okay, what if we did -6 H plus now? -6 H plus, so that becomes 0. And crap. Yeah, -6 H. No, -6. What am I doing? 6 OH. And 6 OH. We did that now.
Like to both of the balance equations.
Yeah, well, yeah.
I added 6 OH to just the Br one without the Mn. So I did
Okay,
each of the half.
but you're going to end up with some H plus over here if you don't add it to this side as well.
I just think I did it this way. Because I would do each half reaction.
Are you looking at this? And you're getting the right answer?
Yeah, I'm getting the right answer.
Test your method on the next one, and if you think it works.
Okay.
I'm going to teach one method.
Okay, sorry,
Just
I
to
was just
keep,
confused.
it's okay,
with
no,
that.
no, you're thinking outside the box, I'm cool with that, I'm just not sure. But if we did that now, you follow your method and tell me if it's working.
Okay.
This book does mention doing OHs a slightly different way, but because this way always works, I just stick to one method because it always works. Rather than have to think on my feet somewhere in the middle and go, hey, can I do OH at this point? So maybe you're onto that. I'm just going to keep following the process. What's next? Where are we? Charge balance both sides. What do we get for that? +5. So what do we do? What are we at here? 6. Okay. And over here we added. Okay, and then we got to multiply through here by 2. 2 times 3 is 6. 2 times 4 is 8. Times 2 times 2. 2 times 2 is 4. Chop out the electrons. So yeah. Now at this point, I wouldn't have a problem with adding, instead of bringing everything down, you could go ahead and go, I've got to get rid of all these H pluses, and I have to add the same amount of OH to both sides. So I'm going to add 8 OHs here. See, we added 6 OHs before I got to this step, so I'm not sure how you can figure that out. Remember, I had 6 OH here before I did that, and now I'm writing 8 OH.
Like how I know how to do that?
Just follow your method, see if it's fine with me, if it works, then solve it however you want. So I'll put these together, what do I get? 8 H2O. And I put these together, I get, here's what happens if I put these together. I get 6 H2O plus 2 OHs left over. You see that? You do end up with some OH at the end sometimes. And that's why I think your method is going to fail once we get to one of those. No, this one has 2 OHs at the bottom. Okay. Where are we? Okay, so I'm just going to bring these down. They're not going to change. 2 Br negative plus 2 NNO4 negative. So I brought those two down. I've taken care of that. I've got 3 H2O over here. So do notice I've got 8, 9, 10, 11 H2Os on this side, because I already had some H2O. And then I created 8 more. So don't miss that. Okay, I took care of those for this. We have 4 H2O. That. And then I'll block the 2. Br. That's those 2. So I have 11 H2O here. You see that? 11 H2O. And over here, I've got 6 plus 4, I've got 10 H2O because of that. And I've still got 2 OH. Okay, so I've got this 11 H2O, the Br, the MnO4, the BrO3, the MnO2, 10 H2O, and OH. So there is one more thing to do, is to get rid of, we can subtract 10 H2Os away. So we'll be left with an H2O here, and these 2 things. these two things, and no H2O, but we're gonna have those two things and 2OH in the answer. So the overall answer is, if I wrote it up here, 2 there, H2O, and then what else? PRO3, 2 of those, PRO negative. So that's where we end up landing. All right, I'm curious with your method. Did you go on to the next one?
I'm still working on this one. I'm like still on that. Takes me a minute. I can tell you what I have today.
Okay, let's try the next one. I'm curious if your method works now, whatever it is you're doing. I think if I try to mentalize your method, I'll get confused. I'm leaving it up to you to see if it works. LH4 minus. That. The AL's balance, the carbons balance, everything else is hydrogen and oxygen. So let's start with oxygen. There's no oxygen up here. Down here we've got 1 and 1. Those balance. I guess we're not adding water here. Okay. 4 H's, so over here I've got 2 H's and 4 here, so I'm going to put plus 2H plus here. Is all that correct? Before I go on. So charge balancing, we're definitely positive over here and negative over here, so we've got to add negative charges over here. 4H plus 3 more. So we're at 7 plus, and we need to get to -1. So what is that? Positive over here, neutral over here. We're going to add. What is it? 2. 8 there and 2 here, so we multiply 2 here by 4. 2 times 4 is 8. 2 times 4 is 8. 2 times 1 is 2. 1 is 2. All right. Are you trying your hydroxide method, your OH?
I'm like still on.
Okay.
I take a lot of these.
So I was curious where you got that. Chop that out. I just want to wait to do the OHs at the end, but we could do them now. There's no water anywhere. Do you like doing the OHs here, or do you like getting it all down here first? Huh? That's the way I like to do it. So everything that's left is going to bring down 8H plus 8LH4 minus plus 2H2CO.
Did we multiply 4 to go from that? Because it was 2. We multiplied by 4.
Yeah,
So then it should be 4
can't even do the simplest math.
H2CO.
What was this?
That was 2.
Give me four of those, oxygen, carbon's good. Okay. And then I wanted to multiply by 4.
Yeah.
Okay. Put it on here. 2 times 4 is 8. 4 times 1 is 4. 4 times 1 is 4. There, is that correct?
Yes.
Yep, almost went by there. Okay, chop this out. What just happened? Wait a minute. This is 2. And then we did 2 electrons here.
Yes.
Okay, now I multiply by 4. This times 4. This times 4. 4. Okay, did I do that right? That's 8. Now is it right?
Usually 8H plus.
Is that right or 4?
Yes.
It sure feels like a Friday. Alright, so that. Okay. Gotta get rid of all the H pluses, and I'm going to add the same amount of OH to both sides. So how many OHs am I adding? 8. 8. OH gives me, what's this stuff? I'll do. This stuff down. And now I'm going to add 8 OHs up here. And that's going to give me 4 waters with 4 OHs. Last step, subtract the 4 waters from both sides. So now we just get rid of as much water as we can. Minus 4H2O gives me none of that. Minus 4H2O gives me 4H2O plus 8H4 minus 4H2CO 8L3 plus. There's no water left. So now I'm just going to add the 4 OHs. 4 OH, 4 of those, 4 OH, 4 of those, okay. All right, it's correct with your help. 6. Do you want to do more of these? They're all the same. You guys good? I feel like we've done enough of them. That same method for every one of them should work. If you see any of these in here, I went through it trying to take the ones out that were good for it. This guy obviously loves these. Whoever made this website. Here's an interesting example, and he shows something kind of odd and off. Like, no, go back to the non-interesting examples. But, all right. So those are from that website.